Okay, now that you've thought that, let's talk about some powers and some exponents. All right? Let's say I have 2 to the third power. 2 to the third power is simply 2 times 2 times 2. Okay, and that's not 6. That's 2 times 2 is 4, times 2 will give me 8. Okay? 2 to the fifth is going to be 5 of them. 2 times 2 times 2 times 2. So there are 5 of those. Okay? Same thing here. If I had 3 to the 4th, that's going to be 3 times 3 times 3 times 3. Okay? So the exponent, the power, tells you how many times you're multiplying it by itself. Now there are a couple of cases. You can have 2 to the 0, or 3 to the 0, or 4 to the 0. These all equal 1. Any number raised to the 0th power equals 1. Doesn't matter what it is. It could be a billion to the 0th power. It's going to be what? Always. Okay. If you have 2 to the 1, that's going to be equal to 2. 3 to the 1 is going to be equal to 2. 3, 4,000 to the 1 power is going to be equal to 4,000. If you raise a power to 1, it's just that number. Okay. So we normally don't write the 1. We usually just write the number as itself. Okay. Any questions so far? All right. So let us see what happens when we start combining these guys. What would happen if I said I want to do 2 to the 4 times 2 to the third? Well, we know 2 to the 4 is equal to 2 times 2 times 2 times 2. And then we're multiplying by 2 to the third, which is 2 times 2 times 2. Right? So we end up with 1, 2, 3, 4, 5, 6, 7. 7. Well, if I have 1, 2, 3, 4, 5, and I end up with 2 to the 5, I have 1, 2, 3, and I end up with 2 to the 3. If I have 1, 2, 3, 4, 5, 6, 7, I'm going to end up with 2 to the 7. All right? Well, looky there. A 4 plus a 3 is equal to 7. Let's see what happens if I try a different number. 2 to the 2nd power times 2 to the 8th power, 2 times 2, then I've got 8 of them. 8. 1, 2, 3, 4, 5, 6, 7, 8. All right? 5, 6, 7, 8, 9, 10. Equals 2 to the 10. 2 plus 8 gives me 10. So, if I have the same base, which is this big number here, and I'm multiplying 2 of them with different powers, I can just add the powers. So generally, it's if I have some number a, and again, we're using a as a variable, so it stands for any number we want, raised to some number m, again, variable standing for any number we want, times a, again, it has the same base, to the n, again, any number we want, we're going to end up with a to the n, a to the n plus n. We just add the powers. If the bases are the same and you multiply, you can just add the powers. Okay? Well, since we're doing that, let's see what happens when we divide. Let's say I had, let's go with 3's now. Let's say I had 3 to the 7th divided by 3 to the 3rd. Okay? That's 3. 1, 2, 3, 4, 5, 6, 7 divided by 3 of those. Well, we can cancel these guys. So we're canceling this one, canceling this one, canceling this one. And remember, just like cross-canceling, 3 goes into itself 1, so these all become 1s. But we don't have to write them as 1s. Okay? So that's going to give us, how many do we have left? 1, 2, 3, 4. 3 to the 4th. So if we're dividing them, just like we showed here when we multiply them, if they have the same base, we can just simply subtract the exponents. So if we have some number a raised to some number m divided by that same number a raised to some number n, we simply subtract them. So anytime you have the same base, you're simply going to, if you're multiplying, you're adding the exponents. If you're dividing, you're subtracting the exponents. Well, since we're having so much fun with exponents, let's move on. I know I'm having fun. I hear you guys over there just laughing and giggling away, so happy because you love math, right? Oh my gosh, you guys are like, oh, can we have more math? I know it's 12 o'clock. I know we want to go home. I just want to stay a little bit longer for some more math. Just a little bit, please, can you? I can. So let's say I had 2 to the 3rd power, and I was going to raise that to the 4th power. Well, we know if we raise something to the 4th power, it's going to be that times that times that times that times that. That's going to be 2 to the 3rd times 2 to the 3rd times 2 to the 3rd times 2 to the 3rd, right? There are 4 of them, right? I've got 4 of these guys multiplied. Well, each of these guys right? So I've got 4 sets of those. Well, that happens to equal 12. And looky there. 3 times 4 is equal to 12. So if I have a power raised to another power, I can multiply them instead of having to write them all out like this, which would be particularly important if it were something like 30 to the 15 to the 2nd. You wouldn't want to have to write that out that many times, right? So it makes it real simple if I have a to the m raised to the n power. That's going to be a to the m times n. Okay? So these are our rules. And there's one more that we want to cover. So let's go back to this guy before we cover the new rule. What would happen if I had 2 to the 4 divided by 2 to the 7? Okay, well we know using this guy, that's going to give us 2 to the 4 minus 7, which is going to give us 2 to the, using our number line again, we're here at 0, we start at 4, we go back 7, 1, 2, 3, 4, then we have 3 more to go, 1, 2, 3, that'll be 2 to the negative 3, right? Because we're subtracting, we're going that way on the number line. All right, so that's pretty simple. But wait, there's more. Let's multiply it out just for fun, because we love math and we love fun. All right. Well, we can cancel again. So we cancel this, that's left with the 1, cancel that, left 1, cancel that, 1, cancel that. All right, so we're going to end up with 1 over 1, 2, 3, 2 to the 3rd. Huh, look at that. 2 to the negative 3rd is equal to 1 over 2 to the 3rd. Well, that's pretty interesting. So our rule is a to the negative m is equal to 1 over a to the positive m. If we have a negative exponent, we move it to the denominator, the bottom, and make it positive. By the same token, if we had it this way, if we ended up with a negative in the denominator, we could move it to the numerator and make it positive. So if you ever end up with a negative value in the denominator, you just pop it up to the top and it becomes positive. If you ever end up with a negative power here, just pop it to the bottom and it becomes positive. So those are our exponent rules. And quickly, lastly, I want to talk about absolute value. Does anyone have any questions on the exponent rules? Okay, so now I want to talk about absolute value. And then we will stop for the day. I know you guys want me to keep going forever, but I know you guys have things to do. I know you want me to just keep going on and on about math. You're like, oh, please, don't stop with the math. We need math. Okay, absolute value is real simple. If I have the absolute value of 6, I strip away the negative, and I'm just left with a 6. I have the absolute value of 3, that's going to stay at 3. I have the absolute value of 27, it's going to be just 27. Absolute value is simple that way. This is where it becomes fun and tricky. The absolute value of a variable. Okay, that means whatever number I put into this variable, I am going to make it a positive portion. So if I said the absolute value of x were equal to 6, you would say, well, x is equal to 6, obviously, right? Makes sense. If I plug a 6 in for x, I'm equal to 6. However, look, negative 6 also works. That means that x could also be equal to negative 6, right? I can put in a positive 6 here, and I'll get a 6 out. I can put a negative 6 here and get a 6 out. Okay? So here, our answer is positive or negative because whatever ends up being in here, we strip off the negative, and that becomes our absolute value. Any questions on anything we've covered so far? All right, so next week we will cover, there's no school on Monday, so we will cover statistics, and then we'll move on to the next section. Any questions? Are you sure?
Yeah.
Because I had so much fun. All right, okay, thank you. Remember, tomorrow morning and every morning for the rest of your life, you're going to wake up and you're going to say, not like that, you're going to say, there you go, I like that, because you can't be good at things you hate, right?
Yes.
There's no school Monday, it's Labor Day. All right, thank you very much.
Or this Friday.
Oh, it's Friday, yep.